no force but one. Gravity pulls, the fall's begun. No engine, rope, or push in sight. Just Earth calling through the night. Mass don't matter, big or small. We answer the same silent call. Velocity keeps changing fast as seconds quietly pass. I'm in a free fall, pulled to the ground. Acceleration always constant now. 9.8 every second down. No air resistance around. I'm in a free fall, law supply, physics written in the sky. Distance.
First thing first, you can refer to textbook page 46. First thing first, we have to know what is the meaning of the theory of free fall, the definition. Jeremy, can you read it?
Free fall, motion of an object influenced only by gravity, no air resistance, no other external force.
When you refer to textbook page 46, maybe there are some different words because actually it's the same meaning, but with another words, simple words. Next slide, please. Okay. The gravitational acceleration. Okay. On Earth, our Earth, all objects fall with this same acceleration, denoted as g, regardless of their mass. 9.8 watt. 9.81. 9.81. Okay. This is the formula we use for calculate the value of free fall. This G only. Okay. I want to ask you, when you concept in Malay, bila kamu tengok formula this G formulas last week, if you remember, can someone answer me? It's found from the page 35. The linear motion equation that we learned before, right? It's still the same, but there's only one difference. Who can spot it? G. Okay, what's the difference? Okay, in the linear motion equation that we learned before, we use A, right? A stands for acceleration. How about free fall? Okay, just as I said before, for the free fall theory, we use gravitational acceleration. That's why we use G. We don't use A. Okay, get it? Okay, and then for the formula for free fall, we only use first, third, and fourth linear equation, motion equation. Why? Later I will explain it. Okay, yes, please remember the formula. Okay, the first question. Okay, this one is example of A. Okay, the first equation. A ball is dropped from a height of 45 meters. Right. How long does it take to reach the ground? From the atas sekali until the ground. Simple, right? Okay. Given U is rho, what is U? The unknown U stand for what? Initial velocity. How about X? Displacement. Okay. How about G? Okay. And then we already did the formula. Okay. Use this formula. Like this. Okay. This is how you calculate it. It's so simple actually. Okay. You try to press it in your calculator. You try to see, is it correct or not? Sorry for the data. It's a font problem. This one, small t, small letter. Okay, this one is. This is the real question. Okay. We have two questions. Okay. I'd like to test you guys. You can write it on post-it paper, on Anything up? Okay, we try to answer these two questions. Then I need two people only to write it.
An experiment of volleyball and feather on gravity and air resistance. As you guys know, the definition of free fall is just gravity, but we will test gravity and air resistance. Okay, if we drop bowling ball and feather at the same time, which one do you guys think will hit the ground first? Okay, that's correct. The bowling ball. Okay, what if we remove the air resistance? Okay, first I will explain why the feather not falling down first. Because of the air resistance push up the feather. Okay, now we will remove the air resistance. If we remove the air resistance, both of these will stay. They will go down at the same time. That is what we call free fall. That if we have air resistance, that is not pure free fall. But if we remove air resistance, that is a pure free fall. Okay. That is it. You guys can answer the question.
You guys can try what's up? 5 minutes for these two questions. Doesn't change. It's always 9.81. It doesn't change. Step 4, free fall theory. Okay, you have to memorize this one. It doesn't change. No matter what, where you at, as long as at the top. Okay. Please.
Information given in the question. Okay, it say coconut falls from a tree and it takes 2 seconds. Okay, that is the first information you got, and then it hit the ground. Okay, calculate the velocity. So the question 1 is calculate velocity. Now we have this information, and first we use the formula. G, we must remember G always is. Okay, this is the top. Okay, after we write all the information we know, we can start use the formula that calculate it already. Okay.
Released from rest, no force but one. Gravity pulls, the fall's begun. No engine, rope or push in sight. Just earth calling through the night. Mass don't matter, big or small, we